Okay guys, applying the Hungarian algorithm to the first example, find the smallest number in each row. So here it's 37, so I'll be taking 37 away from each number there. I'll be taking 26 away from each number here, and I'll be taking 34 away from each number here. So 37 take 37 is 0, 40 take 37 is 3, 38 take 37 is 1, 28 take 26 is 2, 32 take 26 is 6, 26 take 26 is 0, 34 take 34 is 0, 38 take 34 is 4, 35 take 34 is 1. Now find the minimum number in each column, so that's 0 there, 3 there and 0 there. So where it's 0, that's not going to change. 0, 2, 0 and 1, 0, 1. But I'll be taking away 3 from each number in this column. 3 take 3 is 0. 6 take 3 is 3. And 4 take 3 is 1. Now I put vertical and or horizontal lines through all the zeros, and I can put 1 through there. You always put the minimum number through. And I used 3 lines to cover all the zeros, and there were 3 rows or 3 columns in the original question, so that means I can find a solution. So now you look to see which worker should be allocated to which task. For worker C, there's only one task that they should be allocated to, and that's X. So worker C does task X, so no one else needs to do task X. Worker B must do task Z, so worker B task Z, and that would leave worker A to do task Y. So going back to the original, so A does task Y, A does task Y, that's 40. B does task Z, so B does task Z, that's 26. And worker C does task X, so C does task X, that's 34. And when you add all of those together, 100, minimum cost of 100. All right, next example. Find the minimum number in each row and take that away from each number. So I'll be taking away 8 from each number there. I'll be taking away 9 from each number there and taking away 11 from each number there. 25 take 8 is 17. 8 take 8 is 0. 15 take 8 is 7. 23 take 9 is 14. 9 take 9 is 0. 14 take 9 is 5. 23 take 11 is 12. 11 take 11 is 0. 13 take 11 is 2. Now find the minimum number in each column and take that number away. So I'll be taking 12 away from each number here, 0 here, and 2 away from each number here. 17 take 12 is 5. 14 take 12 is 2. 12 take 12 is 0. This column of zeros doesn't change. 7 take 2 is 5. 5 take 2 is 3. And 2 take 2 is 0. Now I put horizontal and or vertical lines through, but here I've only used 2 lines, but my original question was 3 rows or 3 columns. So what I now do is find the minimum number that is not covered. So in this case it's 2, and I take 2 away from each of the uncovered numbers. So 5 take 2 is 3, 2 take 2 is 0, 5 take 2 is 3, and 3 take 2 is 1. So now anywhere where the lines intersect or cross over, like here, you add 2 on there. So I would put 2 onto here, and you just put the other numbers down, the zeros, as they were before. Now I have to use 3 lines, or I could have used 3 I used 3 horizontal lines, or I could have used 3 vertical lines. In any case, I've used 3 and there were 3 rows or 3 columns in the original question, so I can find a solution. So here I look for a row where there's only 1 0, and that's here. So that means that worker A must do task Q. If worker A is doing task Q, then worker B has to do task P. Worker B, task P. And that would leave worker C to do task R. Now going back to the original, so worker A is doing task Q, so that's 8 hours. Worker B is doing task P, so that's 23 hours. And worker C is doing task R. Worker C is doing task R, which is 13. Now when you add all those up, 6, 14, that should be 44 hours. So 44 hours is the minimum amount of time for those workers to complete those tasks, with each worker doing only one task. When you come to class tomorrow, could you please write your name on a small piece of paper and write the word Honeyjoy or the words Honeyjoy underneath it and hand it to me as you come in. Thanks guys, I'll see you then.